Hello everyone, welcome to the eCYBERLESson classroom. My name is Matt Hartman and I'll be your instructor for this lesson. Today, we'll be looking at conducting an experiment. We're going to begin with an experiment that's already designed. The problem we're going to try to solve, or the question we'll be answering, is how many drops of water can fit on a penny? You're going to find out the answer to this question through experimentation, following the instructions on the Penny Lab instruction sheet. So, get your materials together and follow the instructions on the sheet. Pause the video while you do that and answer the questions on the sheet. Hello again. So how many drops of water fit on your penny? I bet it was more than you thought. Did you get the same results every single time? Probably not, but I bet it was at least close. Or maybe one of your trials was a number that was very different. Did you figure out some reasons why that may have happened? Let's go to our Army scientist, who will talk to you a little bit more about this problem.
Getting different results, or not being able to repeat your results, is a real problem for scientists. They must be able to reproduce their findings, and other scientists must be able to as well to make sure that what they have discovered is accurate. Sometimes different conditions can yield different results, so it's important to conduct multiple trials to make sure that the results are accurate. Oftentimes, investigations can lead to new questions, and so now we will take your discoveries with the penny and see what other questions we can come up with. Take a look at Student Sheet 6-1. The Independent Investigation Guidelines. Start thinking about conditions you could change about the penny or the water that might yield different results. Make sure you come up with your independent and dependent variables and write out a good hypothesis. Make sure the test you decide on is safe. It should not involve any unknown chemicals, fire, or really anything that has the potential to harm you in any way. And make sure you get approval from your parents before you try any kind of tests, even if you think they're 100% safe. So go ahead and work through Student Sheet 6-1, answering all of the questions. Pause this video while you do so. Okay, so you should have an experiment ready to go. It's time to conduct the experiment and collect data. Pause the video while you do so. Welcome back. Hopefully your experiment went well. If you want to see how well you did, check out the Independent Investigation rubric and see how well you scored. I'm an Army research engineer, and I work on developing protective clothing against chemical weapons. These weapons can be in liquid, gas, or particle form. My team and I develop clothing that's meant to be worn individually by the soldiers as uniforms, so I have to think about how well he or she will be protected from bad chemicals while being comfortable enough to do his or her mission. In my field, we measure chemical protection by challenging these fabrics against liquid, gas, or particles that mimic these chemical weapons. On the other hand, we can measure comfort by how much air can get through it, because fabrics that are more breathable are more comfortable than ones that are not. Experiments in my job are used to understand how well we've developed protective clothing that balances these two things. We may hypothesize that adding a protective coating to a fabric will prevent a hazardous chemical from passing through it. In this case, the type of protective coating is my independent variable, while how much hazardous chemical passes through is my dependent variable. We test the protective ability of our coated fabric several times to make sure we are getting the same results to make decisions on what coating is best. Sometimes, when we don't get the same results after repeating it several times, we realize that the way in which the coating was added to the fabric was not consistent. This leads us to start asking questions like, how can we add this coating so it's the same every single time we test it? Which can then lead to new hypotheses and experiments we can form. Now let's go back to your eCYBERLESSON teacher.
And now it's time to go on to the next lesson, drawing conclusions. Remember, if you have any questions or problems, talk to your team advisor. If there are still questions, you can contact Cyber Guides on the forums at eCYBERmission.com or call Mission Control between 9 a.m. and 5 p.m. Monday through Friday at 1-866-GO-CYBER. See you soon!